Hello everyone. As I read the earlier video about the reagents class 1, so that was with a bad voice control. So here I am making a more video of class 1, which gives a relatively better voice control. So in the reagents, first of all, we are going to know what are reagents. So reagents are the chemical entities which will convert the starting material into the desired product. Okay. So any chemical that will convert the starting material into product, we can call it as a reagent. But here we are mentioning desired product, means what you are going to expect that must come from the reagent what you have used. Okay. So knowing the reagents will leads to desired product. So by making the desired product, you can convert any starting material into any product by the application of the required reagents. So that is the main application of the reagents. So you must know that are the prescribed reagents which can convert the one functional group into the other functional group. Okay. So when it comes to category or classification, reagents are three types. So basically, reducing agents, oxidizing agents, and organometallic reagents. So these are three types that we are going to discuss in our syllabus. So reducing reagents, which will reduce the starting material and convert into the product. Okay. So what is meant by reduction means addition of the hydrogen or removal of the oxygen. So in terms of oxidation also we can say if it is decrease in the oxidation state, we can call it as a reduction. If it is increase in the oxidation state, we can call it as a oxidation. So the reagents which will reduce the starting material and convert it to the product that are said to be reducing agents. The reagents which will convert the starting material into the product based on the oxidation, they are said to be oxidizing reagents. So organometallic reagents can also act as a reducing as well as oxidizing, but they are made up of organometallic compounds where carbon and metal bonds are present. That compounds are said to be organometallic compounds. So the reagents which are made up of the organometallic means carbon metal bond is exist in the reagent, that are said to be organometallic reagents. Why we need to classify the organometallic reagent into separate ways? Their application is very much enhanced when compared to the other reducing agents. So these are the next generation reagents and the catalysts. That's why we are especially emphasizing our focus onto the organometallic reagent as a separate class. Okay. So the first reagent, lithium aluminum hydride. So lithium aluminum hydride. So what is meant by lithium aluminum hydride? Lithium aluminum hydride. Okay. So here if it comes to structure, aluminum is the middle one and the central atom, and it is assisted with the 4 hydride which is H minus. Why H minus? Because hydrogen is more electronegative when compared to the aluminum. So as the aluminum is third group, its valency is 3 and its covalency is also 3. When it is exceeds one bond with the H minus, it's going to occupy the negative charge. So this negative charge will be stabilized with lithium as a positive cation. So overall it is sp3 hybridized and tetrahedral in shape. So and negative charge will be assisted by the aluminum, which can be stabilized with the lithium plus cation. Okay. So in lithium aluminum hydride, the active partner or active reagent is H minus. Okay. So active reagent is H minus, which is going to act like a nucleophile as well as the base based on the reagent systems and reaction systems. then this H minus will be going to attack on the electron deficient positions. Okay, either it may be carbocation or it may be carbonyl carbon or any other. Okay, so these two are electron deficient positions that are readily accept the nucleophile. Okay, so this is basic idea of the lithium aluminum nitrate. Okay, so if it comes to preparation, the lithium aluminum nitrate can be prepared in two methods. One of the method is lithium hydride with AlCl3 combination to give lithium aluminum hydride, and the byproduct is lithium chloride. The second method is usage of the sodium and aluminum in the presence of the hydrogen. Okay, to form sodium aluminum hydride. The sodium aluminum hydride can easily replaced with the lithium when in the presence of the lithium chloride. So again you are going to get lithium aluminum hydride. So the first application of the lithium aluminum hydride. So here, as I said, lithium aluminum hydride active partner is H minus, which can act upon the electron deficient positions like a carbonyls. So carbonyls may be aldehyde, may be ketones. So both the aldehyde and ketones can be converted into the alcohol. So if it is aldehyde, it's going to give primary alcohol. If it is ketone, it's going to give secondary alcohol. Okay. So this is an example of the ketone converting into the secondary alcohol. Okay. So when it comes to the mechanism, is the nucleophilic addition of the carbonyl carbon. Okay. So where hydride can act as a nucleophile, and this hydride can attack on the nucleophile as a nucleophile to the carbonyl carbon, which will converting into the O minus, that will be stabilized with Al. Okay, to give aluminum assisted oxide. Okay, so this process is repeated 4 times as the 4 hydrides can attack on 4 carbonyl carbons. So after attacking the 4 carbonyl molecules, it will be converted into tetraaluminate. Okay, tetraaluminate oxide molecule. So this can be easily hydrolyzed using H3O plus R acidic water to result alcohol. Okay, so here for the 1 mole of lithium aluminum hydride, 4 moles of the carbonyl carbons can convert it into the alcohol. Okay, sometimes number of moles can also be asked in questions. Okay, so as you understand the mechanism, so the mechanism will be similar to the all the compounds. So everywhere nucleophilic addition is the main reaction, which is nucleophile here is H minus. Okay, so we're going to see the next application. So in the next application we're going to see the reduction of acids. So carboxylic acids are oxygenated functional groups which can convert it into the alcohols. So all the carboxylic acid will result into the primary alcohols. So this is a specific example of the conversion of acid into the primary alcohols using lithium aluminum hydride. Here diethyl ether is the solvent. Okay. So when hydrates or metal reagents, if you are using, it must be noted that you should not, the reaction system should not contain water. H2O is prohibited when using the metal reagent and hydrate, because hydrates and the metal reagents vigorously react with water so that they can be explosive. So diethyl ether is one of the dry solvent which can make the reaction system free of the moisture. So the next application, reduction of esters and halides. So these are the oxygen functional groups. Okay, so these are also converted into the alcohols. Okay, esters, if it is breakup, it will be the ketone part. Ketone part also converted into the primer alcohol, and alkoxy part also converted into the primer alcohol. If it is amide, this part is going to convert into the direct amide. So amide, if it is amide, it's going to convert into the amide. So if it is ester, it's going to give alcohol. If it is alcohol acid, it's going to give alcohol. If it is carbonate, it's going to give alcohol. Only if it is amide, it's going to give amide. Okay. So complete oxygen elimination, that is what complete reduction is going to happen here. Okay. So this is specific example of conversion of diester into the dialcohol system. So this other part also converting into the alcohols. Okay. So this is the specific example of the conversion of cyclic amide into the cyclic amide. Okay. So now we are going to see the other applications. Reduction of nitrogen functionalities. So like azides. So N3 acid to the azides, nitrous, that is what we can commonly say cyanides, nitrocompound. These all are nitrogen functionalities which can further reduced into the amides, simply amides. Okay, all acids and azides and nitrocompounds can convert into the acids by using lithium aluminum nitrate. So everywhere the electron deficient position is going to occur by nitrogen. So nucleophilic addition reaction is the main reaction that is going to happen in all the reducing reactions of the lithium aluminum ion. Next, the final application, reduction of the epoxy. So as the active part of the lithium aluminum hydride, H minus, which will go and attack on the lesser side or less steric hindered side of the epoxide, so that it can open the epoxide ring. So this is what H minus is attacking here, and O minus is going to generate. This O minus is going to supply with the proton by the source of the proton, which is maybe solvent or maybe the pinching agent, that is what water. Okay. So epoxide opening is a stereospecific reaction. It must happen with the low steric side and low substituted side. So as the epoxide is above the plane, attack must be below the plane. So below the plane is going to happen. Okay. So this is H minus. Already hydrogen is present from the so that's okay. So these are the applications of the lithium aluminum. Now the assignment. So here the assignment is so make a lithium aluminum hydride table or chart with including all the functionalities. Aldehyde, if aldehyde, what happens? If ketones, what happens? If acids, what happens? Okay. If esters, what happens? If amides, what happens? And if it is nitriles, what happens? If it is azides, what happens? If it is amides, what happens? Okay. So send this chart through WhatsApp. Okay. So that I can understand. You are able to understand the reagent system and able to apply this. Okay. If possible, send some applications or some examples of the reaction that you have encountered with. Okay. So this is the assignment for today. If everybody submitted the assignment through the WhatsApp, I will start the next reagent. Okay. Thank you.